Welcome back to Topic 1 for Algebra 1, PEMDAS and Properties of Real Numbers. In Part 2, we're going to learn about the properties of equality and use what we learned in Part 1 about PEMDAS, the properties of real numbers, and our newfound knowledge of properties of equality to solve some examples. So what is the property of equality? Basically, what you do to one side, you have to do to the other side of the equal sign in order for the equation to remain balanced. So we have it broken up into addition, subtraction, multiplication, and division. For addition, we're going to start off with an example to kind of demonstrate it. Let's say we have 5 equals 5. On the left-hand side, if I add 1 to that 5, I must do the exact same thing to the right-hand side for my equation to remain balanced. If I simplify this, 5 plus 1 is 6, 5 plus 1 is 6, 6 equals 6. For subtraction, similarly, we do the same thing here. What we do to one side, we have to do to the other side. Let's say we start off with 7 equals 7. If on the left-hand side I subtract 4, then I must do the exact same thing on the right-hand side. 7 minus 4 is 3, 7 minus 4 is 3, 3 equals 3. For multiplication, I'm going to show two different examples here. I could start off with 8 equals 8, and if I multiply 2 on the left-hand side, I must also multiply 2 on the right-hand side. 8 times 2 is 16, 8 times 2 is 16, so they're equivalent. But what if I have a sum? So I don't just have one number, but I have a sum of 2 or more. What if I have 5 plus 2, for example? So 5 plus 2 equals 5 plus 2. And again, these are very basic examples. As we go further into algebra, we'll get more complex examples and even some examples involving variables. So say I want to multiply the left-hand side by 4. I can do the exact same thing on the right-hand side. Now on the left-hand side, let's say we want to solve this by using the distributive property. So 4 times 5 plus 4 times 2. On the right-hand side, we can solve using PEMDAS. So simplify in my parentheses first. 5 plus 2 is 7. And then we would multiply it by 4. On the left-hand side, if we simplify, 4 times 5 is 20. 4 times 2 is 8. And 4 times 7 is 28. Now, 20 plus 8 is 28. So it matches. For division, we can have 6 equals 6. Now on the left-hand side, if I want to divide 6 by 3, I can write it like this. However, on the right-hand side, let's say I want to write it as 6 divided by 3, so it looks like a fraction. Now this division sign on the left-hand side is definitely more traditional, but we can also demonstrate division on the right-hand side using a fraction. So note, whenever you see a fraction, you are actually seeing division. So we can read this as 6 divided by 3 is 2, and 6 divided by 3 is also 2, so it's balanced. Let's move into some examples. In this first example, we have this long expression, and we're going to solve it using PEMDAS. Now remember, we want to work from left to right, but if we see multiplication and division, or addition and subtraction, we can solve whichever one of those we see first. So looking through this example, we have 12 minus 5 plus 6 times 3 plus 20 divided by 4. The first operation, since we don't see parentheses or exponents, we're going to see if we spy multiplication or division first. Now going from left to right, we see multiplication first. So I'm going to simplify this. 6 times 3 is 18, and it's a positive 18. Then I'm going to rewrite the entire expression all over again. So 12 minus 5 plus 18 plus 20 divided by 4. Now this is my new expression. So I'm going to read from left to right and see if I see any multiplication or division first, since we don't have, again, any parentheses or exponents. Now I don't see any multiplication, but I do have a division right at the end here. So I'm going to simplify that. It may be tempting to want to either add or subtract, since the rule is to go from left to right, but we have to keep in mind that we have to go in the order of PEMDAS too, down the line. So 20 divided by 4 is positive 5. My new expression is 12 minus 5 plus 18 plus 5. Now here, we're going from left to right. We have subtraction, addition, and addition. Because we see subtraction first, going from left to right, we're going to simplify 12 minus 5, which gives us 7. So 7 plus 18 plus 5. Now this is all addition, and actually using the commutative property, we could flip the order and still get the same exact answer. So we can add all these together, 7 plus 18 plus 5, and that gives us 25 plus 5, or 30, as our final answer. For number 2, we have negative 16 equals d minus 9d. Now, if we look on the right-hand side, what we first need to do is actually something called combining like terms. And that's because we have the same variable raised to the same power. We'll get more into exponents later in the Algebra 1 curriculum. But here on the right-hand side, we have d minus 9d. Now this is really 1d, not One Direction, but 1d minus 9d. So if we kind of eliminate and forget about the d variable first, what's 1 minus 9? It gives us negative 8, negative 8d specifically, if we take into account that variable. So negative 16 equals negative 8. Now, in order to solve for d, we want to get rid of this negative 8 here. So we're going to use the division property of equality, because what we do on one side, we have to do on the other side. So we're going to divide the right-hand side by negative 8 and the left-hand side. And we will end up with negative 16 divided by negative 8 is positive 2. Remember, negative divided by negative is a positive. So d equals 2. Perfect. Moving on to example number 3, here we have another example involving PEMDAS. Here we have parentheses first. So I'm going to simplify in my parentheses. 2 plus 4 gives me positive 6. So we have 5 squared divided by 5 times a positive 6. So parentheses, check. Next we'll move on to exponents. 5 squared, also known as 5 times 5, which is 25. 25 divided by 5 times 6. Now moving from left to right, we have division and multiplication. Now we have to think whichever one comes first. Division we see before multiplication, and since those are in the same level, we're going to simplify our division first. 25 divided by 5 is 5. Bring down my times 6, and then we can simplify. 5 times 6 is 30. For number 4, I want us to also solve for this variable x right here. So in order to do that, we're going to first subtract 5 from both sides. We see a positive 5 on the left-hand side, and we want to use the inverse property in order to cancel it out. So the opposite of positive 5 is negative 5. Since we did the same thing on one side to the other, we use the subtraction property of equality. So we're left with 3x equals negative 30 minus 5, which gives us negative 35. Now we still want to isolate that variable here, isolate that x. Since this is really 3 times x, the inverse of multiplication is division. So we're going to divide both sides by positive 3. Since we're doing the same on one side as we're doing on the other, this is the division property of equality. Now looking on the right-hand side, we have negative 35 divided by positive 3. Since 3 does not evenly go into 35, we can just leave this as a fraction. So our final answer is negative 35 thirds. And that's it. Thank you for watching Topic 1 for Algebra 1, PEMDAS and Properties of Real Numbers.